Hello again, Ben here, and welcome back to my channel. So today is October 18th, and we are here for a short video for two things. So one, we are going to check on our field, see how it's doing, and then two, we are going to look at the results of our carbon testing of our two biochar attempts. So hang on, and I hope you enjoy. So it has been 3 weeks since my last video, and a lot has changed over here. So as you can see, our miscanthus has tassels on it now, so these are the seeds that it produces. Unfortunately, these seeds are not viable. Well, it's a good thing and a bad thing, I suppose. So these, obviously are the seeds that it makes, and as I said, they're non-viable, so you can't propagate it via seeds, which is why we are looking at our rhizomes and our stem cuttings. But also, that is also good because they're also not invasive, meaning that you can plant it and it won't spread beyond the, vegetative propagation that it has. So we can see that all of the miscanthus has the tassels on it, basically, and it is starting to die off, actually. So we had our first frost here a couple of days ago, and that has started the process of senescing the above ground biomass. So what is happening basically is that everything above the ground is starting to die off, and all of the nutrients are being sucked back down into the roots for next year. So that will help everything to dry out, and then after that is complete, we will cut it down, grind it up, make it into pellets, and turn those pellets into biochar to finish the carbon capture process. So just seeing that there's still a lot more to go in terms of the drying anyway, but as you can see, some of these stems are quite high, probably 10 feet tall, I would imagine, which is a good thing. So we are going to just wait until this is fully dried. The leaves will fall off, as I mentioned previously, and then we will take the stems, cut them off at the base, grind them up, and make charcoal out of that. So that is the plan. And right now we are just waiting until the drying out has completed. So as I talked about in a previous video, I was going to send out samples of these for analysis. So I did that, and now I have the data, and we are going to talk about that data real quick. So what I sent out was the wood pellets themselves, and then this is our first attempt in making biochar, and then our second attempt in making biochar. So I sent out samples of each of these for analysis, and I have the data, and we are going to talk about it right now. So first thing I'm going to talk about is this sample right here. So what I sent out for is a CHN test, carbon, hydrogen, and nitrogen test, finding the percents of each of those in the sample. And how they do that typically is they take a small bit of sample, they burn it, and look at the CO2, the water, and the NO2 that comes off of the sample. And all of the CO2, water, and NOx, I guess, are that they find in the air is from the sample itself, and they are able to tell based on the weight of sample how much carbon, hydrogen, and nitrogen were in there to start with. So why this is important is that it tells us the elemental composition. So I'm not sure if you can actually read this or not, but the wood pellets here were sample number 1, and they had 47.76% carbon, which is interesting to us because that means that these are almost half carbon, which is, what all biomass is, approximately between 45 and 50% carbon. But why that's interesting is that this is carbon and not CO2. So if you took 100 pounds of wood pellets based on this 47.7% carbon, 100 pounds of wood pellets is actually equivalent to 175 pounds of CO2. So that's why it's useful for us to use wood pellets, because it's a lot easier to, store these, move these as a solid, non-reactive sample. It's a lot easier to move them as wood pellets than it is to move it as CO2, because obviously that's a gas, you have to contain it, all the difficulties therein. So it's a lot easier to, store and move wood pellets than it is CO2, and that's why we are using, wood pellets instead of just capturing straight CO2 from the air. One of the many reasons anyway. So That's basically all that was interesting about sample 1. So sample 2 here, this is our first sample of our biochar, and this was made non-quantitatively, so I don't know how much I started with or how much I ended up with, but I did look at the elemental composition here, and this stuff is 83.14% carbon and 2.51% hydrogen. So what we are looking for is a hydrogen to carbon ratio of 0.2 or less on an atom basis. So not on a percent, obviously, 83% and 2%. This is a hydrogen to carbon ratio far under 0.2, but if you look at the actual number of atoms, obviously carbon is 12 and hydrogen is 1. So the actual hydrogen to carbon ratio for this sample, our sample number 1, was 0.362. So that is over the 0.2 threshold that we are looking for, because anything with a 0.2 or less threshold, or sorry, anything under 0.2 or less in terms of the hydrogen to carbon ratio is basically stable for a very long time underground. So that is what we are looking for, to not just lock away our carbon, but make sure that it stays there for centuries. So that was sample number 2. And then sample number 3 is here, and we actually did weigh this sample. So we know that we started with 8.17 pounds of wood pellets in our little burner that we use, and then had 58 pounds in our 10-gallon drum. So that was a total of 66.17 pounds of wood pellets that we used. And then we know that we got 14.71 pounds of biochar at the end. So if you take the ratio, so this is 86.30% carbon compared to 83% carbon, and that higher ratio is because this was better insulated, perhaps it burned hotter and potentially faster. So the higher the temperature in general, the more stable the char that you get from it. So because this had the thicker insulation and it didn't melt and all of that, it had a more complete conversion to charcoal. So this actually is 86.30% carbon compared to 83 and change. So this carbon to hydrogen ratio for our most recent burn, our sample number 3 on here, our second biochar, is 0.186, which is under that 0.2 threshold. So this stuff is stable, will stay in the ground and not break down for centuries. This is what we are looking for. So we know, because of our elemental analysis, that this carbon is very stable and is of a grade that we are looking for and will, stay stable for centuries. So we can count on these credits as being good, because this stuff is not going anywhere. It'll stay there, and it will, hold the CO2 that it has captured for a very long time. So also, if we look at the math, so we had 14.71 pounds of charcoal, and we started with 66.17 pounds of wood pellets. So if you look at the math and you do the math of the number of carbon in your starting material versus the amount of carbon in your finished product, we were hoping for 50%, but if you do the math, you actually get a little bit over 40%, which is still pretty good. So that's still not ideal, but certainly high enough for what we are looking for. So most importantly, big picture here is that our carbon is going to be stable for a very long time, which is good, and our yield is 40.16%, not amazing, but still, reasonably good. Certainly able to move forward with at that yield. So this is basically what the elemental analysis told us, is that the durability is good, the yield is a little bit less than we wanted, but still okay. So that is what, information we are able to take from the testing that we did. So today we saw that our field has tasseled out and that it is starting to senesce or die off. And also we learned that our charcoal making process works in that the charcoal is very stable because it has that hydrogen to carbon ratio of under 0.2, which is good. And also our yield is approximately 40%. So the next step for me is to wait until this stuff behind me dries enough for pelleting and harvesting, basically. So the next video you will see from me is the first step in the harvesting, which will occur honestly whenever it's ready. So I'm hoping for a month or so, but we'll see. We're looking for about 15 or 16% moisture in the material for us to harvest. So once it hits that, I will harvest it, pelletize it, and then turn it into charcoal. So until then, thank you for watching, and I will see you next time.